Hi, good evening everyone. Today we will be discussing the boiling water reactor, a type of nuclear power generator that plays a crucial role in producing clean and efficient energy. Our presentation will cover the fundamental principle of its operation, its advantage and its significance in modern power system. Let's dive in. So for the second slide, we have 5 of them in our group and we are from group 4. So my name is Darwin Shah, CN230036, and my friends Roshan Analaki Rajkumar, AN230126, Muhammad Shamil bin Suhaimi, CN22071, and Amirul Ajay bin Abdullah, CN220031, and finally Arish Ramsurya, CN230100. I will start with the introduction. As the name suggests, a boiling water reactor uses water as a coolant and as a moderator. Extremely pure water flows around the primary circuit and through the core, where nuclear fission generates heat. Water in the primary circuit is hot, heated to around 285 Celsius and is permitted to boil, only reaching pressure up to 7.5 MPa, 75 times greater than atmospheric pressure. The steam generated occupies about 12 to 15% of the volume of the reactor pressure vessels. After being dried by steam separators, the steam flow directly to turbines within the primary circuits. As the turbines spin, electricity is generated.
Okay, for the next part, we use uranium-235 as a fuel. Uranium dioxide fuel pellets is enriched with uranium-235. So these are housed in fuel rods. So for the additional effects, the BWRs can last up to 2 years without being refueled. So for moderator, boiling water reactor use light water as the moderator to slow down the nutrients, such as poison, gadolinium can be introduced to control the rate of fusion. And lastly, coolant. A boiling water reactor uses light water as the coolant as it's not pressurized. It is permitted to boil.
Hi, good day everyone. My name is Roshan and my matrix number is AN230126. Now let's talk about one of the key safety features of the boiling water reactor, BWR. The BWR is designed with the containment shielding that surrounds the reactor pressure vessel. This shielding plays a crucial role in safety. It prevents any radiation from escaping into the outside environment, protecting both people and nature. What's interesting is that this shielding is also reinforced to protect reactor from external threats. It can withstand extreme weather events like hurricanes, impacts from missiles, and even airplane crashes. In summary, this robust containment design ensures that the reactor remains safe and secure under various conditions. Thank you.
Okay, next for characteristic for safety measurement for implementing nuclear power generation. Firstly, location is within 50 km from international boundary. Selecting a site in the international border require further consideration in safety, security and safeguard of NPP. Second, location is within 15 to 30 km from high density of population. A location further than any population is more favorable as long as it fulfills the operation requirement of NPP. Third, location with undulating of or unstable geographical characteristics such as steep land, hills and mine. Last, location is within 1.5 to 15 km from protected areas, industrial areas and military base. On our opinion, the first place that are suitable for implementing the nuclear coordination of boiling water reactor first is Mukah at Sarawak. Because Mukah has established energy facilities including coal-fired power plant which can support the integration of nuclear power into the local energy grid. Second, the region is geologically stable, minimizing risk associated with seismic activity, which is important for ensuring the safety of nuclear facilities. And lastly, as Sarawak nation looks to diversify its energy source and meet increasing energy needs, nuclear power that can provide a reliable and sustainable option for the future. The next place that we think that are suitable for implementing nuclear power generation of boiling water reactor is Mersing at East Johor, because the area in Mersing is in the Mukim of Jemaluang and Tenggaro, that both Mukim have 3,000 to 5,000 people that are giving huge advantage for safety measure. Second, emergency support that are provided by that place, such as hospital, fire station and military. And the only disadvantage for implementing nuclear is the area is poor access to the main road, because the area is far from the main city and has low population of people. Lastly, for the conclusion, this project successfully designed and simulate a nuclear generator model with a boiling water reactor, demonstrating its potential to meet Malaysia energy demand sustainably. The integration of PSF simulation and a physical prototype emphasize safety, efficiency, and regulatory compliance, providing a foundation for future investment in nuclear energy system.
I will present the flow and project. So first, water from the sea. So for this project, we suggest two locations, Muka Sarawak and Singapore. So why? We choose the place, the location, because of the location in the sea. So we have other places as well in the sea, but for why those two places are. So it is not a big city, so there will be rural area. So I think Mersing it's also a big city, but Mersing is considered tourist attraction, but part of Mersing is a little bit hidden gems, hidden gems. So if you put this power plant, not for tourism, wanna go, but they're scared. We choose that place because they have safety feature. First of all, near the sea, and second, the population human at that place are not too crowded. Then
what about nearby the ring? So this one need to be supplied to the transmission grid. The location are nearby the grid. Have to find out where is the nearest. Pick along the way a coastal area nearby Mersing, for instance. You will find some area called Kampung, I don't know. And then try to trace the nearest rig for human safety. Okay, when you build it, when you build the nuclear power plant here, then that can be connected to the nearby grid somewhere in this area.
From the water source, we go to containment burning, which uranium 235 as a fuel, and with the help of reactor, it will boil the water and produce steam. The steam will move the turbine and supply it to electric generator. From electrical generator, it will send through transmission line to consumer. For cooling process, the remaining for the excessive water will go back to condenser to the help of cooling tower.
Assalamualaikum. My name is Amirul Ajar bin Abdullah, matrix number CN220031. So today I will present a poster about nuclear power generator with boiling water reactor. So as we know, the rising global demand for sustainable energy, nuclear power as an alternative, offering low emission and high energy output, um, are known for their efficiency and reliability in Malaysia. So transitioning to nuclear energy requires thorough research and model development to ensure regulatory and smooth integration into the nation power grid. So the objective are to design and simulate a nuclear power system using boiling reactor, focusing on key components such as substation, transmission line, and distribution load. So the important component of this generator is boiling water reactor. A boiling water reactor generates electricity by boiling water in its core using nuclear fission, producing steam to drive turbine. So it's renowned for efficiency and reliability for minimized greenhouse gas emission, making it sustainable energy source with safety features. For the next part is cooling tower. So the cooling tower manages excess heat in nuclear power station by cooling steam after it passes through turbines. So the steam is considered condensed into water and recycled back to the reactor for continuous operation. So it's essential for efficiency cooling to help maintain the 30 to 40% efficiency typical of nuclear plants, which have capacities of 500 to 1,500 megawatt compared to thermal power plants. So lastly, the safety features involving multiple protective layer. The key elements include the cryogenic pressure cooling system for efficiency cooling in reactor. So the reactor pump for efficient heat removal and redundant system to ensure reliability. So physical barriers and a reactor containment prevent the release of radioactivity, ensuring safe plant operation.